This is Brian Putt. Today I'm going to show you how to incorporate an ELD into your SIPMath model using the ELD Metalog file available at metalogdistributions.com. I'm going to start from this blank worksheet, and we are going to utilize some raw data that comes from the earlier video. Hopefully you've watched that. We're going to use the steelhead data. So the first thing we need to do is we need to copy all the data, all of our samples. So we'll copy that. And then we're going to go over to this ELD Metalog file. And I've called it the ELD Metalog Equation Maker version 9 Putt because I've made a few little modifications to it to include the mean that we'll see here in a minute. Right now it says invalid input parameters because we don't have any input data. So let's go look at that input. Let's put our input data in there. Control V, and now I have data, and now I have a distribution here. So in the top of this model, we can specify whether we have a bounded distribution, whether we have an unbounded distribution, a U. We're going to bound the lower level, SL, bound the upper level, SU, or both, as we've gotten here. If we do both, we then specify the lower bound and the upper bound. And right now, the lower bound specified as a 2, represented by that red dot. Upper bound is 50, represented by that red dot. We can change the number of terms, and we can see which terms are going to look good based on these little graphs over here. So we can see if I did n equals 2, it doesn't really show me the shape because all these others have a very definite shape. And so we're right now looking at 9. We can go look at 8. Or we could look at 7. And you'll notice that these change just a little bit, but not too much. I don't like this upper bound here of 50. The largest fish we've caught was 33 inches, and it's saying it could be up to 50. I wanted to get rid. Let's try just changing this to a lower bound. Okay, we'll change this to a lower bound. And now we see that we have a lower bound here at 2 still, and the upper bound, the equation goes a little bit higher. It goes up to like 35. Well, it's possible we didn't catch the largest fish possible. So that sounds all right. If I scroll down here, we can see the density function. It shows us kind of two pieces here. Now that we have our curve fit here, with a Metalog of 7 terms and a lower bound, we want to copy this over to our Excel file. So let's see how we do that. We're going to scroll down here, and you're going to see that there's a y, which is a random variable. Right now it shows us 0.25, but we're going to eventually make that a uniform distribution. There's an equation for the quantile function and an equation for the probability density function. But these need to be updated based on the terms that we set up here. So what we're going to do is we're going to say make Metalog functions. Now watch this equation down here change. Okay. So now that we have these, we need to open up an Excel file. And we'll come back to our Metalog. I mean, this file could be open already. And we're going to copy these 3 equations. So I'm going to copy those and come back over to my file, wherever I want them. And I'm going to put them right here. And so remember, this is the quantile function. And this is the PDF. Now, let's make this a SIPMath model. So we're going to say SIPMath initialize of 1,000 things. And let's just define this. Oh, we'll define this as a random variable. Uniform. We'll say yes, because there's something in here. We'll overwrite that. We'll say yes. And now we have these quantile functions in the PDF. We will now make this an output variable. Define outputs. And we'll call it QF. We'll call this PDF. Now, in practice, I think we might take this and put it on a separate row, and then we'd have two different functions here. Or you could keep them like this. Okay, now we want to plot this function. So we're going to just graph it here as a cumulative. Okay, and now we can see that looks very similar to what we had before. So we can see that they're very similar. Although we didn't get down quite as far. That's because of the random variable. We could have done more sampling, and we could have gotten down to this P0, if you will. All right? In any case, it looks similar. And now we want to get the PDF file. Now, to get the PDF, what we do is I need to point out that the PDF and the quantile function are both running off the same random variable, this random variable right here. So what I need to do to get the PDF is to plot an XY graph. And what I want to plot is this distribution on the Y and the quantile function on the X. Now to do that, I have to come over here to this PM table. And I'm going to highlight this PDF, Shift N down, and I'm going to insert a chart, and then I'll chart design, change the chart type, select the data, and now I need to pick the X values. And the X values are going to be the QDF. Because remember, each of these points, these paired points, are working from the same random variable. Okay? And there's our PDF file. And we can compare that to, and they look similar, except this has got some little gaps in it, because this has got, this is plotted 1,000 data points. If I plotted more data points, if I had more data points in the SIPMath, I probably would have gotten further down here, plus I would have filled in some of these gaps here. But certainly I think that's adequate for describing to the decision maker what the distribution looks like. Hope you found this helpful. Thank you. If you'd like to learn more about Metalogs and SIPMath, visit metalogdistributions.com. Go to probabilitymanagement.org. You can read The Flaw of Averages or Chansification, Sam's new book. You can review my many YouTube videos. And you can always contact me at brian@theputz.com with any questions you have. Thank you.